Okay, I think we can start right from the very though this would be a very first lecture, right? And let's start what this DevOps is. So today primarily, and I focus more on it would be theoretical, right? First, I'll just give the glimpse of the tool technology, right? Okay, so first let's try to understand, right, what this DevOps is, right? So I'll not go through this PPT. Okay, I'll simply try to explain you, right, the real concept. Okay, the real world, in the real world what happens. Okay, so here, okay, um, let's take example, right? Uh, you want to do you want to deploy something, right? You want to develop something. Okay, you want to consider that you are working with organization, right, where your organization is expecting you to deploy some sort of application, right? So what you have to do, right? You have to like work with the different teams, especially the development team, right? You have to work with the QA guys, right? Who can like verify your code, right? Okay, who can write the code for you, right? And once that code is like ready, okay, you can run it somewhere. So let me just use a very layman language, then I'll just talk about how this pipeline will look like, right? So simply consider, okay, you have kind of a code, right? Okay, and it could be anything, right? It could be uh, a Java based code, right? Or it could be a Python, right? Or it could be a .NET or XYZ, right? So here, the moment your development team, right, okay, and as we know that for this coding activity, the developers are responsible. Okay, so let me just add here developers. Okay, the development team will be primarily responsible for the coding activity, right? Along with like test cases, and let's say consider that you have everything, right? So now what you have to do in a very simple language, right? What you have to do, you have to take this code and get it deployed, right? Simply copy, okay, copy the code and get it deployed. Okay, so what you can do, right? You can you can deploy to a kind of some environment, right? So here in the right side, let me just add environment. Okay, it could be a it could be a like a virtual machine, right? It could be a uh, cloud VM. Okay, right? Or it could be a Docker and Kubernetes. By the way, I'll just I'll talk about what this Docker Kubernetes, right? Cloud VM, but let's just think about kind of an environment, right? Or think about like in a platform, right? So we would need a platform where I can deploy the code, right? I can run my code, right? So here, when I say environment, basically, we would need a platform, right? Okay, and this platform I can build using a cloud VM, right? Or I can deploy it in a company-based, company-managed data center, right? Your organization managed data center, okay? Or I can deploy it to Docker or Kubernetes, right? Based environment, okay? Right? Or I can deploy it to some serverless components, okay? So let me just add here. Serverless applications, right? Example, AWS Beanstalk. Okay, I'll talk about all the tools, whatever I'm going to write, right? We'll see later on. But here, let me just note down some terms here, right? Or it could be a Azure applications, right? Or it could be a GCP, right? Or it could be a Lambda, right? So here, we would need a platform, right, where I can deploy the code, right? So here, as I said earlier, you'll be closely working with the development team, right? Who is going to write the code for you. Okay, as I said, it could be a Java, it could be Python, it could be .NET, right? It could be C#, it could be anything, right? So as a DevOps engineer, what you have to do, right? You have to take this code and get it deployed, right? You can deploy it on one of the platform, right? And as I said, it could be a cloud platform. Okay, it could be your company managed data center, right? Or it could be a Docker Kubernetes, right? Or it could be a serverless platform, right? So here the problem is, as you can see here, right? We cannot directly copy the code and get it deployed, right? We have to follow some process here, right? So here, as you can see, there's a huge gap, right? Okay, there's a gap, right? And as a DevOps engineer, we have to fulfill the gap, right? So here, then this DevOps part will come in picture here. Okay. So using the DevOps tools and technology, okay, using DevOps tools, we can fulfill the gap, right? Using DevOps tools, DevOps technology, right? Or DevOps principles, okay? So here, when I, when I talk about like a DevOps, right? So here, this DevOps is nothing but what? Development plus operations, okay? Right. It means, like there are two parts, right? You need to think like, from the development side, right? So what I'll be doing, I'm going to explain, in a different way, right? So that, you can actually understand what this DevOps is, right? Okay. So DevOps is not about, DevOps is not just about like tool and technology, right? It's like, I would say, a kind of your, you can simply follow some principles, right? It could be like a strategy, right? So here, and you are completely free to use any tool, right? There's no definition that you have to go ahead with Jenkins, you have to go ahead with GitLab, you have to go ahead with the GitHub Action, right? You can even, if you're comfortable with the coding, if you're comfortable with the Python code, right? You can go ahead, you can use that Python code just to get it deployed, right? Or if you don't want to use any tool, right? Okay, if you don't want to use any script, right? What you can do, you can create your custom tools, right? Okay, and using this custom tool, you can fulfill this gap, right? So DevOps is all about, okay, principles, right? So here, when I talk about this dev part, okay, so here, this is how how this picture gonna look like, right? So earlier I just gave you one example, right? In this picture, in the previous picture, as I said, you'll be closely working with the development team, right? So let me just add here one developer, okay, like dev1, dev2, right? You may have a kind of a team, right? And you'll be working with them, right? So here, what this person is going to do, right? This person is going to write the code, right? And then this code can be stored on a central repository. Okay, so here the GitHub, okay, GitLab, Bitbucket, right? Primarily, we in most of the organizations, right? I would say, even if you talk about like Fortune 500, right, or Fortune 200, 2000, right? So in most of the organizations, you'll see GitHub, GitLab, Bitbucket, right? This are like some, the code repository tool. I'll just, give you an example. Let me go here, okay, and let me just open the GitHub. This is how that. If you're completely new, then you'll be able to like understand. 1 second, let me log in. Okay, so you can see here, like in my case, I do have. Let me just click here. Okay, so as you can see, right, I have more than like 290 or nearly 300 like repositories, right? So what you can do, right, in the organizations, okay, you can simply create some sort of repositories, right, where this entire code can be stored, right? For example, if I open this one, let me just let me show you one quick example here. Okay, you can see, right, this particular repository, okay, where you can see here there are some code repositories like this is a like one example, okay, related to the Python. You can see here there are a couple of Python related files, right? So here what we can do, okay, in the organizations we can use GitHub, GitLab, or Bitbucket, right? This type of code repositories where the entire code can be stored here, right? Along with your coding, right? All the test cases, right? Whatever the data, right? Whatever the code, whatever the language, that you have, all the files can be stored here, right? So let me just add here, okay, SRC, so that it would be easy for you to like understand. You can have all your test cases, okay, test cases related files, right? Then as a DevOps engineer, okay, you also need to contribute, right? Okay, means you need to ensure that this process is like automated, right? Because in the previous example, in this previous picture, what I said, right, you had to fulfill the gap, right? So as I said, to fulfill the gap, you can use a kind of a script, or you can use Jenkins, you can use GitHub, right? So what you had to do, you had to write some sort of script, right? You had to write some kind of a the process, right? Some stages need to be defined, okay? So for that, as a DevOps engineer, okay, you'll be also responsible for, let me just add here, DevOps, right? So you'll be responsible for, okay, writing the Jenkins file, okay? So as a DevOps engineer, okay, you need to work on Jenkins file, okay? You can write the Docker file, okay, where you can have all your like instructions, okay, how the applications can be built, right? You can have Terraform, okay, means you can provision the environment, right, in automated way as well, right? So this Terraform is is like one of the provisioning tool, right? So you can have all the Terraform related files as well, right? You can have if you want to deploy on Kubernetes, right? So you can write Kubernetes related files. Okay, you can write the Helm chart, you can write the Kubernetes, right? And you can also define some networks. You can define your rollback, right? You can define storage, right? Where to store the data and everything, right? We'll see in those topics, right, during our Kubernetes. So apart from this, okay, Ansible, okay, will come in picture, right? Especially for configuration, right? Okay, so that you don't need to configure, you don't need to modify your environment manually, right? Okay, if you want to automate the process, okay, especially if you want to install something on a particular, let's say in the previous example I just gave, I said like to deploy your application like on a cloud VM, right? So I need to ensure that this cloud VM is capable enough to run my application, right? Okay, for example, if I want to deploy a Python application, so I need to ensure that Python is installed on this VM, right? If my Python along with all the dependencies, right? Okay, only then the applications can be, we can deploy applications, we can run applications, right? Okay, so here if I want to, if I want to run my application right on cloud VM, right, or if I want to run my applications on organizations, your company managed VMs, right, or in Docker or Kubernetes, right. So I need to ensure that my tool is present, right. So here, this Ansible part will come in picture, right. Even I can start the process, right. I can I can configure it, right. I can automate some processes, right. So here this Ansible part will come in picture. So as a DevOps engineer, okay, what I have to do, um, I I need to write, okay, Ansible playbooks, okay. In we actually call it like an Ansible playbook, right. Where you can have some instructions, right. So those instructions can be executed via CI/CD based approach, right. Then you can have some scripts, okay, deployment script here. Let me just add here deployment scripts, okay. Let me do one thing. Let me increase the font. So what you can do, you can write like a deployment script, okay. So if you're comfortable with the Python, right, you can write this deployment script in Python, right. If you're comfortable with PowerShell, you can write the deployment script in PowerShell, right. Okay, if you're comfortable with the Linux shell script, okay, you can write the deployment script in Linux, right, or you can in shell. So it's up to you, right. As I earlier said, this DevOps process, okay, we have to refine, right. As a DevOps engineer, as a DevOps architect, we have to decide, right, this strategy, right. Okay, what would be our deployment strategy, right, which tool to use, right. And there are some conditions, okay. Even I'll talk about like this tool decision part in the upcoming lectures, okay. As a like architect, right, as a strategic architect, how we can choose a correct tool, right, so that this process will be smooth, right. So here I can write some sort of scripts, okay, and using this script I can automate my deployment process, right. And there are other couple of files, right. So as a DevOps engineer, primarily will be working on this type of a files, okay. You need to write the files, and what you can do along with your source code, okay, you can upload all these files to this particular repository, right. Let me just add here one or two. Okay, let me not add here. I'll just show you example as well. So let me go back and open one of the repository. Okay. So here, you can see, right? Um, yeah, you can see here, like there are some, the source code, right? You also can see here, you have the Docker file, you have the Jenkins file, and you can have other sort of scripts, right? Based on your your like CI/CD approach, right? So along with the source code, okay, you can upload all these files, right? So once you have all the code, right, in the GitHub or Bitbucket or in the GitLab, right, then the build part will come in picture, right. So here you need to ensure that you execute all your test cases, right. You compile the code, right. You perform some sort of I would say steps, okay. So the next part would be, let me just add here one more picture. Okay. So we'll do a lab with Jenkins, right. So let me just add here Jenkins, but in your organizations you may have GitLab runner, okay. We'll not do lab with GitLab runner, by the way, but we'll focus more on like Jenkins. You may have GitHub Actions, right? Or you may have Azure DevOps. By the way, Azure DevOps is part of our course, right? So I'll show you this Azure DevOps as well, right? Where we can write, where we can perform our continuous integration process here, right? So these are some tools, right, that I'm going to use specially for build activity. So let me just add here, okay, build path, okay, or I can perform the continuous integration process here, okay. So in this continuous integration process, right, what I'll be doing, right. So here, what I have to do, first I'm going to pull that code, okay, on this Jenkins server, right? So once I had the code, right, what next, what I'm going to do, right? I'm going to ensure that I'm going, first, the very first thing is that I'm going to check that, this code is correct or not, right? Okay, the code has any leaks or not, right? So in real world, what usually we do, we just, perform some like git leaks. Okay, I can check if there's any some sensitive informations are not, right? If there's any token, if there's any sensitive informations, like, let's say a DB password, right, or DB strings, okay, or if there's any deployment token, right? So it happens, by the way, right? Whenever we work like with a development team, when we work with, the QA guys, right? Or even when we work with like a junior DevOps engineer, right? It's possible that if there's any sensitive informations, right? Even before we deploy, right? Okay, before we deploy, or even we before build it, right? We need to ensure that, we should have like some git leaks type of a process or stage, right? Where I'm going to scan my entire code, right? And if there's any sensitive informations, okay, then I'm going to fail my job here, right? So that, we'll get the feedback in very early stage, right? So here I'm going to perform some git leaks here, git leaks related stages. Okay, let me so here, even you can perform some other stages as well. You can perform lint, right? You can uh, uh, perform some lint code kind of stages here. So you can verify that the code is correctly lint or not, right? Right, the code is created correctly or not, right? So if there's any, it happens, by the way, like nowadays, very well that people usually use like Chat GPT, right? Okay, or Gemini, right? Okay, especially just to generate the code, right? Or if people are copying the code, right, especially from the Google, right? It is possible that the code is not properly linked, right? So what, as a DevOps engineer, is our responsibility, okay, that we introduce such stages, right, in our continuous integration process, okay, just to lint the code, right? So if there is any linting error, we can immediately notify our development team, right? So we should have some stages here, right? Then we can perform, okay, we can do the code compile, okay. So here we can compile the code, right? If there's any error, right, if there's any syntax error, okay, if there's any let's say executions error, right? So those errors can be detected in very early stage, right? So what I can do, I can execute the code compilations state here, right? So when I say code compilation, I need to use some tools here, right? As I earlier said, okay, you are completely free to use tool. So for Python, right, like for Maven, okay, we will be using a different tool, right? But if the source code is like Python, you have to use a different sort of tools. Okay, if your code is like .NET, you have to use a different tool, right? So for every stage, right, for linting, okay, for Python, you have you can use the Python, right? Python lint, right? For code compilation, if your code is like a this Java, you can use Maven, you can use Gradle, right? You can use End for this code compilation. Okay, so based on your code language, you have to use a respective build tool, right? Even I'll talk about that later on, right? Even I'll share list later on, okay, especially during the Jenkins topic, and then we'll see the build tools. Okay, we'll talk about the build tools, and we'll do a labs as well. So here I'm going to perform the code compilation state, right? It means if there's any error, okay. So in the code compilation, what happens, right? It basically, okay, converts the code from from high level to low level, right? So that your system can understand. So when I say system, right? So here especially in the code compilation, right? I'm going to compile my code here, right? Okay, I'm going to convert the code, right, from Java to a low level, right? Okay, like means 0 and 1, right? Because the system understand only binary language, right? Okay, for system, right? System won't be able to understand, right? The Java, Python, right? Okay, system understand your low level languages only, right? So what I had to do, I had to compile the code here. Okay, if there's any sort of errors, okay, we can immediately generate a code compilation report, right? And we can send it back to the development team, right? So here the best part of this DevOps is what the feedbacks can be shared immediately, right? So let me just add here one more part. Okay, if there's any sort of error, right? Let me use different color here. Okay, so if there's any error, what this process is going to do, this process is going to notify your developers, right? Notifications. Okay, so we can notify, okay, the our teams. Okay, we can notify our QA guys, we can notify developers, right, that the code is like not correct, right, or there are some compilation errors. Okay, there are some I would say sensitive informations, right, or the code is like not linting properly, right? So all we can send the notifications to our team here, right? This is what as a DevOps engineer you have to create, right? And when we are going to create the CI/CD pipeline, right, in our upcoming lectures, I'll show you how this notification things can be enabled, right? Then what happens? Then once my code is like compiled, right, I can build the code. Okay, so let me use the black color here. We can build the code. Okay, so here what I'm going to do, I'm going to generate a compile a deployable package here, right? So here generate deployable package, right? uh, it could be it completely depends, right? It completely depends what type of a what language, right, you are using, right? If you're Java, you can generate jar, er, or a var type of a artifacts, right? If you have Python, you can generate Python script, you can generate some Python files. Okay, so it completely depends on your again source code, right? So here my next goal would be, I'm going to generate a deployable package, right? Sometimes we also call it as like an artifact. Okay, generate artifact, right? So this artifact I'm going to deploy, right? So here so once the artifact is there, right, I can execute my test cases. Okay, if there's any sort of like test cases, I can execute those test cases. Okay, so that we can see that the code is the code will work or not, right, properly when I'm going to deploy it, right? So if there's any error, especially during this code executions, right, or unit test executions, if there's any error, I can notify my QA team, right, so that the team can fix the test cases, right, immediately, right? So here I need to perform some sort of unit test execution related steps, right? The next part would be Sonar here, right? Means I'm going to SonarCube. Okay, so here what I'm going to do, I'm going to generate some sort of reports. Okay, report generate. So in this report generate, what type of report, right, I'm going to generate, right, as a DevOps engineer. So here in this report, I'll ensure that we have some code kind of a code coverage, means okay, how many test cases are passed or failed, right? Let me just add here. Okay, passed or failed test cases, right? So here you can generate how many test cases are passed, fail, right? If there's any error, warnings, okay, those things can be generated here, right? So if there's any code warnings, right, or if there's any vulnerability. So the meaning of this vulnerability is like weakness in your code. Okay, weakness in your system, right? So example, if the team is using, let's say Python, right? Again, Python, for example. So if the code is based on Python, right? And if there's any particular library which is, not updated, right? So any hacker, right? Any hacker can use, right, that vulnerability to get into my environment, right? When I'm going to deploy my application, this vulnerability, any hackers or any bot, right, can use this vulnerability, right, just to get into my environment. So here I need to ensure that, okay, I perform the Sonar Cube stage, right, where I'm going to not generate only the code coverage, but I'm also going to see, okay, if there's any weakness, right, okay, if there's any like vulnerability in my code or not, right. Apart from this, okay, related to the security, right, also I can generate, okay, if there's any bugs, right, or if there's any, what happens, people, as I said right earlier, nowadays people are using, Gen AI especially to generate the code, right. So now question is, how as a DevOps engineer, right, okay, as a DevOps architect, now I'm responsible, okay, I need to ensure that this generated code is as per my organization standard, right. So here I need to ensure that, we perform some security scans here, right. Okay, so here in the Sonar, I can do that, right? Even there are other couple of security tests that we have to execute before we deploy, right? So there are multiple type of testing. I'll talk about that during our actual lab. So here I need to ensure that I'm going to not generate only the code coverage report, vulnerability, some security reports need to be generated here, right? And there are some other reports, okay, that I can generate, right, during the build process itself. So if there's any error, right, okay, if there's any, let's say, some vulnerabilities are there, right, I can immediately notify my development team, right, and team need to fix it, right. They can update the code again, right. They can update this code again, they can push the code, right, and then again the whole process will start, right. So this process is going to be continuous. That's why we call it as like a continuous integration process, right. This is what, as a DevOps engineer, you'll be doing. The next part would be, I can store the artifacts, right. Okay, there are other couple of like stages, we can have many other like stages, but let me just talk about like some standard like stages here, right. So next, what I'm going to do, I'm going to store my artifact, okay, like publish artifacts, okay, the artifact which we have like generated. Now the artifact can be stored, right, in central locations here. So JFrog in real words, okay, or Nexus, right. These are some famous tools that people usually use to store the artifact, right. So that if you want to deploy, right, any older version, right, consider that you have deployed today, right, and some customers are complaining, okay, that the application is not working properly, okay, your application, some functions are not working, right. So what you can do, right, you can deploy the older version, but you need to ensure that you store the you're like storing the old artifacts as well, right. So here this publish artifact things will come in picture, okay. So I need to ensure that my artifacts are stored, right, artifacts are versioned, okay, so that in any cases I can deploy, I'll be able to deploy any old versions, right. So here this publish artifact stage is would be one of the stage through which I can store my artifact to a central locations, right. So this process, right, this particular process called this continuous integrations, right, where I'm going to build the code, I'm going to perform some like scans, right, and I can generate the artifact, right. So this is what the continuous integration is, okay. So let me just add here this process I'm going to call the CI, okay, or the continuous integration process here. This is what the CI is. Okay, so there's one question from Rajeshwari. Artifact can be published to S3. So as I said, Rajeshwari, yes, you can use any, right? You are completely free. Okay. Let me just add here S3 as well. Okay, you can publish artifact to S3 as well. Okay, there's no issue, right? So here, you are completely free. Okay, as I already said, you are completely free, okay, to choose a tool, right? So if you think that, if you are completely using AWS like services, okay, then S3 would be the better choice, because you can like save some cost. You don't need to use one additional tools, right? Okay, to store the artifact, right? Because S3, in the S3 we can simply enable the versioning, right? We also can implement some best practices as well, right? Okay, the artifact can be replicated to different regions as well, right? So yes, S3 is also one of the like solutions where artifact can be stored, right? Okay, what about if we want to keep?
I have a question here. Can we store the artifacts in the container registry also?
Okay, so now the example which I'm giving right now, okay, is basically for the VM based kind of a deployment, right? Maybe I'll just do one thing. For container solutions, I'll create a different pipeline. Okay, is that okay? For container, for Kubernetes deployment, our pipeline would be a bit different, right? So the process which I used here, I'm going to modify some stage, okay, uh, so that the artifact, I don't need to publish it to S3. I don't need to publish it to like a Nexus. Okay, instead I can create a Docker image, right? So my pipeline, the flow of pipeline would be a bit different, right? Especially for Docker and Kubernetes, in case of Docker and Kubernetes. Yeah. So I'll talk about that as well. Okay, there's one more question from Haris. What about if we want to keep everything in on-premise? See, as I said, Haris, like you can, you're completely free, right? You need to ensure that you use correct, you have the tools, right, installed on your local system. Okay, especially in your company manage like a data center. So GitHub, GitLab, Bitbucket, right? So like there are two type of a GitHub, a GitLab, Bitbucket, right? Okay, one which is managed by the online versions, and the second one are you can manage in your organizations, right? Okay, you can purchase like the enterprise license version. You can create a VM, right? And on those VMs you can install the GitHub, right? Means the whole environment now will be managed by you, right? So you don't need to use the online version of a GitHub, right? You can have it in your organizations as well. Okay, so this is also possible. And in terms of a Jenkins, so as I said, Jenkins is like one of the tool. Even the Azure DevOps is also one of the tool, right? So like again, there are two type of Azure DevOps. Okay, one is which is managed by the Microsoft, like the online version, and the offline version. Again you can create a VM, and the Azure DevOps package can be installed on that VM, right? And then you'll get I would say then the entire things will be managed by you only, right? So it's also possible. Yeah. Okay, so far let me know if you have any questions from this particular picture. If not, then I'll continue, right? So right now the picture which I'm showing you, right, or the picture which I have created mainly for the VM based deployment, right? For Docker and Kubernetes, the pipeline, the flow would be slightly different, right? So I'll create a new picture, and then we'll see how things actually works in case of Docker and Kubernetes, right? Okay, so no queries. Okay, then let's continue. So now okay, there are two questions. One from Ray. VM-based deployment are for Microsoft or for Azure? As you said, right, Ray, it could be okay. So VM-based deployment, right, is possible for for Azure. It's possible for on-premises and also possible for AWS, right? You don't need to you're not you can deploy it anywhere, right? So as I said in this picture as well, let me just go back to this picture. So as I said, you can have the VM based deployment, right? You can have VM in cloud, right? It could be Azure cloud, right? Or it could be a AWS cloud, right? This VM, or a GCP. You can have the cloud VM in one of the cloud vendor, right? if your organizations, especially for I would say, I can understand your questions, because nowadays what happens, especially in the for fintech, right, type of organizations, um, still you'll see this data centers things, right? So yes, we can have a VM, we can have a virtual machines in the company managed data center, right? And then my the I just need to create some deployment strategies only, right? Okay, I just need to create some deployment script, and then I need to set my target to this company managed data center VM, right? So then I can deploy to company managed VMs here. It's also possible, right? In terms of, again, Docker Kubernetes, right? So I can have this Kubernetes environment in AWS VMs. I can have the Kubernetes environment in my company, in my organizations, or I can use the cloud Kubernetes solutions like EKS, AKS, right? So anywhere, right? Irrespective of the platform, you'll be able to deploy using the CI/CD based approach here, right? I hope I answered your question. Okay, one more question from Pankaj. Do we run Sonar scan for every build? So as you said, Pankaj, yes, is necessary. Here I'll talk about eventually, during the Git topic, I'll talk about this branching strategy, right? Means you may have multiple branches. You may have one release branch. You may have development branch, right? You may have feature branches. So it's good idea that you run the Sonar, right, on all the branches, because consider that you are developing a feature, right? Okay, you're a DevOps guy, and if you're working with the development team, right, and the team is developing a new feature, right? So question is how the team will get to know that, okay, the feature is ready, right? The feature is bug free, right? The feature, what the code, right, they have written for this particular feature, like there's no warnings, right, there's no vulnerability. So it's a good idea that we run Sonar, right, for every build, right? We can run the Sonar for feature branches. I mean, if you're not coming from DevOps background, then this branching would be a bit would be like different, would be difficult to understand at this point. But don't worry, I'll talk about that this branching concept later on. But for right now, just think, right, that whatever the branches, right, whatever the code you have written, right, you need to ensure that you run Sonar, okay, so that if there's any error, if there's any vulnerability, or if there's any security bugs, right, we can identify in very early stage, right, so that it would be easy for us to fix it, right? This is what the DevOps is. Okay. Okay, there's one more question. So as you said, like Pankaj, if you are if you are like changing the code, right, on your local system, right, so you have to ensure that you build it locally first, right? You need to ensure that you are doing some code compilations locally as well, right? But when it comes to the CI/CD pipeline, right, so yes, if there is any particular change, so your continuous integration process, okay, is going to execute the Sonar, right? So then Sonar gonna see, right, what are the changes that you have done, right? They are as per the standard rules. Okay, so in the Sonar we can enable rules. Basically, during the Sonar topic, I'll talk about how can we enable the rules, right? How can we create the quality gates, right? So we need to ensure that the quality gates, right, for a single line, right, or for the entire code should work, right? So yes, is going to execute. So there's one question from Karthik. Can we also automate this Sonar scan process, like auto scan whether there is a change? Yes, Karthik, we can do that, right? So in Sonar, in the CI/CD, yes, we can simply add some conditions, right? When to run the Sonar, right? Okay, when to execute the Sonar, right? So the Sonar can be executed on particular branches, right? Okay, or if you are doing, if you're, let's say, we can ignore the Sonar on some specific branches. So this is possible. Yeah. Okay, let me just show you how this Sonar gonna look like. Right now, I don't have the complete setup, but let me just show you a picture. So this is how this Sonar. Let me click on image, and you can see here, like this is what I was talking about, right? Let me open this picture. So you can see here, this is what I was talking about, right? So on SonarCube, right, I can see how many bugs are there, right? Okay, means and how many vulnerabilities are there, right? So as I said, the vulnerabilities are nothing but like weakness in your system, right? Okay, if there's older version, right, of a particular library, then we need to ensure that we have the updated library, right? So here you can see the bug and vulnerability, and here you can see 0 bugs, and the this code is like A graded code, right? We can mark the code, right? We can mark the code like A, B, C, D, right? We can assign some grades as well, right? Then you also can see here we do have this code smell. Okay, we have basically the duplications, right? So here the code like smell basically some problem, right, or some design flow, I would say, with your code, right? So you can see here there are some technical depth, right? These are some technical terms, by the way. Maybe I'll talk about during the later on. But here you can see there are some code smells, okay, some problems, right, or some design flaw with your coding structure. That's why there are some code smells are there. Duplications, what happens, people usually duplicate the code, right? Okay, especially as I said, right, development team, right? Okay, as I earlier just give this example. Nowadays, what happens, people usually generate the code right from GitHub, GitLab, or this code copilot, right? So yes, chances are very high that you know if there's any duplications, right, if the function is like written twice, okay, so we can detect in very early stage, right? So if right now, as per this example, 0% duplications are there, right? So this is how that dashboard will look like. Okay, so here, as I said, the Maven, especially Maven will come in picture during here. Okay, even let me just note down some commands as well, so that it would be easy for you to understand. So the Maven will come in picture somewhere here, right? Especially for this particular portions. Okay, so here I can use Maven. I can use a build tool, or rather I would say build tool here, because Maven is is like a build tool. And in the bracket, let me say Maven and Gradles, right? Or MS build. Don't worry, I'll share a picture, proper picture later on, right? Or the documentations as well. So these are some build tools, okay, that we will be using it, right, for code compilation, for building the code, right, for generation, artifact generations. Okay, so the build tools can be used here, and these are some examples of the build. Okay, so then let's continue. So the next part would be, okay, the deployment part will come in picture here. So first, as I said, let's take an example of the VM-based deployment, and then later on, I'll just create one more picture, especially for Docker and Kubernetes based, like Kubernetes CI/CD, right? How that flow gonna look like. So, especially for the VM-based deployment, right? What I can do, right? I can create different environments here. Okay, let me just give an example with DevQ in production. Okay, so I can have this dev environment. Okay, consider that is like it could be a cloud VM, as I said earlier. It could be a cloud VM, or it could be a your VM in the data centers. Now, even for creation of this VM, earlier, as I said, right, this Terraform, okay, Terraform, right, or Ansible will come in picture. But for that we can write a separate CI/CD, right, and we'll do a lab as well, right? So now even I don't need to create any VM manually. this is what the requirement, right? This is what, we as a DevOps engineer, you have to think, right? So what you can do, you can write Terraform script. Okay, so again, that pipeline, this is how that pipeline gonna look like, by the way. Okay, especially for this Terraform pipeline. Okay, so now what you can do, you can write a Terraform code here. Okay, means again, you need to write a multiple YAML, by the way. Okay, so this would be your GitHub again. This would be GitLab or Bitbucket. Okay, what you can do as a DevOps engineer, right? You can write Terraform code. Okay, you can write Terraform code on your local system. Okay, and then just publish it to this GitHub repository, right? And then the Jenkins will come in picture again here, right? Okay, Jenkins or Azure DevOps, right? Or AWS pipeline. Okay. Now, what will happen? This time, you need to run Terraform commands. Okay, here, like Terraform init, like Terraform, apply, and so on. There are other commands as well, but let me not go in that detail right now. So what will happen here? You need to download that code, okay, on the Jenkins server or on Azure DevOps server, then run some commands here, right? Okay, and also you can connect to AWS or you can connect to Azure, right? So first connect to, okay, what you had to do, this Jenkins will connect to, right? First, let me just add the stages as well. 1, 2, and 3. Okay. Even you can validate the code, right? Let me, as I said, I have not added all the commands here, like Terraform init, Terraform validate, right? Okay, Terraform apply. So now what happens? This Jenkins gonna connect to the AWS environment. Okay, consider that this is your cloud, AWS or Azure cloud. Okay, the cloud portal, cloud dashboard. Okay, and whatever the configuration, as a DevOps engineer, you can write a Terraform code. Consider that you are writing a Terraform for a VM, right? Okay, you can write Terraform code for AWS instance. So here, what first, this Jenkins will connect to AWS, then Terraform init and Terraform apply. So the moment you execute this Terraform apply, what will happen? One VM will be created in the cloud. Okay, so this would be your finally cloud VM. Okay, so this VM can be created, right? So let me just add here Terraform gonna provision AWS or Azure VM, right? So a VM will be created on the fly, right? Okay, again, I can have Ansible here, but let me not go in that detail right now. So one pipeline, okay. During this Terraform, we will create this type of a pipeline, by the way, right? So using the Terraform, we can automate the process, right? The complete environment can be created, right? So Terraform, will act as like a IC tool here, right? Terraform based CI/CD. Okay, so Terraform will act as a IC tool. Using the Terraform script, I can write the complete, I can create the complete environment. So this VM, right? This is what the cloud VM right now I'm talking about. So here, what will happen? This cloud VM will be created, right, on the fly. Okay, so once this cloud VM is there, what I can do, I can deploy this artifact. Okay, Now let me come back to the original pipeline, right? The CI/CD pipeline for the applications. So here, deploy the artifact, right? So VMs can be created. Okay, the complete environment can be created using the Terraform. And once this VM is ready, what I'm going to do, I'm going to deploy the artifact here, right? So the moment you deploy your artifact, your app, you'll be able to access, you'll be able to run your applications, right? So in this dev environment, my application will be in up and running state, right? Along with that, I need to also, I can have Ansible in between, right? Just to configure whatever like is needed. Let's say if Python is needed, right? What I can do, I can have one more CI/CD pipeline, right, based on the Ansible. And on this newly created VM, I can install the Python, I can install all the dependencies. If the application is Java, then I can install the JDK, I can install all the Java related applications, right? So we can have one more similar pipeline, right? Using based on the Ansible, right? And then finally, the applications can be deployed here, right? So once your environment is up and running, right? Especially this dev environment, now the development team can verify it, right? Okay, the development team need to test it, right? Okay, the application is up and running or not, right? Okay, whatever the functions, whatever the features they have developed, right? And if everything is looking good, okay, then what we can do, we can promote the same package to QA environment. Okay, so here deploy to QA will come in picture. Means I can have my QA environment here, right? So deploy to QA, right? So once the same applications can be deployed here as well. Then you can have integration environment, you can have pre-prod environment, but let me not add here because right now I don't have the enough space here. But later on, let me just add here directly the prod environment. Okay, so you can have some manual approval here, right? Even let me just add here dev deployment automated. Okay, we can have the automatically dev deployment. Similarly, QA deployment I can have again automated, and production deployment I can have manual, means with some approvals. In most of the organizations, by the way, okay, manual deployment to prod. In most of the organizations, you will see the prod environment. We can set, we can trigger manually, right? Means someone need to approve, right? Someone need to trigger the pipeline, right? Only then the package will get deployed to your production environment. So the same environment, right? You can have finally the prod environment here, where you can run your applications. This is how the pipeline gonna look like. In between, I'm going to perform some more testings, by the way, right? Okay, this is how not this is just very overview. But before we deploy to the QA environment, right, we can have like performance testings. Okay, we can have other kind of a testings that we can do, right, in between the QA environment, or in between this QA deployment and the prod deployment, right? So but some more stages can be added here, because we need to ensure that the application that we are deploying to QA and the application that we are deploying to production, right, means I can perform some regression testings. Okay, performance testing, what is the performance right after the deployment, right? Okay, some testings can be performed, but let me not add right now. But yeah, this is how that pipeline will look like. So this particular part, okay, here, this process, basically this would be your continuous deployment, this would be the continuous deployment. So in the continuous deployment, as you can see here, we are deploying to dev environment, we are deploying to QA environment in an automated way, right? Without any approval here, right? Automated. And the continuous delivery, there is one more term, okay, called continuous delivery. So in the continuous delivery, if you are deploying to one of the environment manually, we call it as like a continuous delivery. Okay, so we can have continuous delivery. So this particular term, right, continuous delivery, it means if your process is manual, means if there is any approval, right, if there's any manual trigger is there, then this process, okay, we can call this process as a continuous delivery. So now we have the continuous integration, okay, we can have the continuous deployment. So in most of the organizations, okay, most of the organizations, basically, if I talk about like any product-based organizations, right, okay, be it like Amazon, right, or be it any like banks, right. So you'll see till this QA environment, we can have the automated process, we can have the continuous deployment process. Means if all the gates are passed, I can deploy to QA environment, right, without any human interventions. But for production environment, we can have some, we can set the manual interventions here. Means someone need to trigger it, someone need to approve it, right? Only then the production deployment will happen here. So this is how the whole process will look like, right? Okay, there's one question from Hossein. What is artifact, right? So this artifact here, you can call the generated the package, right, or the package which you are going to uh, generate, right, during the build process. Okay, so in this artifact, we'll be having the required binary, you'll be having the required library files, okay, or the required data to run the application, right? So we can call it as like a artifact, right? So whatever the data, whatever the file is like needed, right? So mainly you'll be having I would say some libraries, okay, or application related libraries will be there, right, in this artifact, right? There's one question from Ruth. Do we need to have deployment to the VM before it goes to the QA, or we can just deploy to QA? So here, Ruth, as I said, now we need to provide one environment. Let me just add here, right? Automated dev deployment, right? So this particular, in the real world, the dev deployment will be used by the development team here, right? Okay. Usually this dev deployment will be accessed by the development team, right? They need to test it, right? Okay, they need to verify whatever the features, right, they have developed, right? What are the functionalities they are like creating, okay? So for their testing, what usually we do, right? We create the lower environment. In some organizations, you will see we actually also call it like a lower environment here. Okay. So here, this lower environment is nothing but your development environment, and this environment will be mostly accessed by your development team, right? Where they can test, right? They can they can verify the features, right? And if the team thinks that the features are not working properly, what they can do, they can modify the code again, right? Then the whole process will come in picture, and the dev deployment will happen automatically here, right? Means whatever that changes they have done, right, okay, they can verify it here, right, in the dev environment. So that's why we usually deploy to the dev environment. Okay, first we can deploy to the dev environment, then we can deploy to the QA environment. Means where all the quality analysis we can perform, right? All test executions can be performed, right? Especially the functional test cases, right? Regressions and whatever the features that you have developed. So this QA environment would be a kind of a replica, right, of your prod environment. Most of the cases, you will see the QA and prod, they both are like kind of identical, right? So we can see the behavior as well, right, of the applications before we release for the customers, right? So yes, we should have the dev deployment, dev environment. We should have the QA environment, and we should have the Indian, I just missed one more environment here, by the way. In in some organizations, you will see int environment, right? Or pre-prod environment, or sometimes, we also call it as like a staging environment.
Staging environment.
Yeah, staging. So, like there are various terms, but as I said, due to this limitation, right, of this picture, but we can have one more environment in between, QA and prod, right, before we deploy to the productions. Okay. There's one question from Rajeshwari. What factors do they consider while choosing the different tool, right? Jenkins, code pipeline. A very good question, right? Let me just explain, right? So here, as a like DevOps architect, right, we have to identify what, okay, is a tool secure, right? What is the cost, right? Is that tool, can we integrate it with the existing systems, right? Okay. How are we going to manage it, right? Okay, who will be responsible for managing the tool, right? Especially the Jenkins, right? The GitLab runner, right? Or the Azure DevOps servers. What is the cost, right? How many customers are going to access? Okay. What is the in most of the cases, right? Especially Azure DevOps, GitHub Actions, right? And Jenkins. Okay. So organizations need to pay, right, for the subscriptions, right? So what that cost is, right? The next decision making, I would say, the factor would be features, right? What are the features available? Okay, how many features are available, especially if I talk about the GitHub Actions or Azure DevOps. So Azure DevOps comes with a lot of I would say features. For example, you can manage your board, right? You can manage your Jira board, you can manage the tickets, right? You can manage, you can perform the test, you can create the not just CI and CD, but you also can manage like a lot of things. Okay, you can manage the user permissions, you can create the users, right? You can create groups. So this Azure DevOps comes with a lot of features. Similarly, the GitLab, Jenkins, okay, they also come with features, right? So feature is also one of the factors, okay, through which based on the features I can decide, right? Let's we can go ahead with Jenkins or GitLab, right, or GitHub or Azure DevOps, or there are other tools as well, right? So I would say there are not just one factor, but there are many, right, that we have to decide, okay, that we have to check before we go for the tool decisions. Okay, there's one question from Pankaj. How frequently we deploy to the production and the UAT? So, in Pankaj, like in most of the organizations, right, we usually follow like 2 weeks of sprint, right, or 3 weeks of a sprint. Okay, and it in terms of a deployment, right? So, especially the production deployment happens if there's any bug, right? If there's any bug or bug is reported by the customers, right? So in most of the cases, in most of the organizations, I'm not talking about the Google, I'm not talking about the Facebook, right? But I would, I'm talking about like, the all other organizations, basically the product-based companies, right? Or in the banks. So, we usually deploy once in a month is usually, the frequency that we, we can once in a month or sometime once in a quarter. But if I talk about the startups, okay, if I talk about the Facebook, Google, right, so they deploy weekly, sometimes daily. It completely depends on what features, okay, or if there's any like incident like reported by the customers, then we have to act, right, and we can deploy to the productions. And if you are developing any new features, right, so yes, accordingly you can deploy to the production. But in most of the cases, once in a month and once in a quarter is these two are I would say the frequency, right, that we usually do, right, especially for the production deployments. And dev deployment, as I said, dev deployments happens every day on everyday basis, right? Because if team is working on any new features, right, or if they are fixing any bug, right, so dev deployment happens on daily basis, right, or sometime multiple times in a day as well, right? This is how we usually go ahead. Okay, so even I can note down that the points here. Dev deployment, as I said, daily. Okay. And why? So that the team can verify. And on QA, weekly, in most of the cases, weekly or bi-weekly, right? It depends. And production deployment, monthly deployment, right? Or quarterly. Okay. So this would be the frequency that, in most of the organizations, you will see, right? Okay, there's one question, right? If multiple people are, working on different feature, right, parallelly. So how are we going to, fix that issue, right? So here, I'll talk about this particular issue during the Git topic, but let me just answer here, right? If multiple people are working on features, right? So what we can, what we can do, right? Let's say consider that, you, me, and right, and one more person. Let's say, I'm working on feature 1, you're working on feature 2, and we have one more colleague who is working on feature number 3, right? So what we can do, I can create one feature branch 1, you can create the feature branch 2, you can create the other colleague can create the feature branch 3, right? So we can create the multiple branches here, right? And then you can deploy, right? You can test it, right? You can verify, okay? Accordingly, you can later on, you can simply raise kind of a merge request, right? If there's any no conflict, okay, then the person who has the maintainer right, or the senior people from the team can accept the merge request, right? So this is how the multiple people can work, right? Now there's one more question here. So aren't there any snapshot versions deployed on dev override by each other? So as I said, in most of the organizations, what we usually do, right? Okay, we test, we can have some dev X environment as well, right? Okay, we can have the local kind of environments as well, right? Where I can test the features, right? So in most of the organizations, you will see common dev environment, right? Where the approved code will get deployed here, right? So no need to create any snapshot versions of dev environment, right? You can create, as like a developer, you can use like SDKs, okay, to test your applications locally, right? This is how we do. Or the other solutions are DevX environment can be created. Like, you can have Dev1 environment, Dev2 environment, where the team can test their features, right? And then, you can have a common dev environment. So this is also one of the possibility that the team, your organizations can decide. But if you are creating multiple environment, like Dev1 environment, Dev2 environment, and the common dev environment, right? Means, consider that in this picture, right? Okay, there are like 2 more environments here, right? Okay, something like this. But then, definitely is going to increase the cost. Okay. So here, you can have some kind of a Dev1 environment here, Dev2 environment, or kind of a DevX environment, rather I'd say. So that is also possible, right? So in most of the, in some organizations, yes, you will see DevX environment, right, where the features can be deployed and tested, right? Okay, there's one more question from Rajeshwari. Is GitOps different from DevOps common practice, right? So here, let me just give you the answer. What this nowadays, you like this GitOps is like a very new concept, right? Okay. So GitOps usually like there are tools, right? Where there are tools like we have the Flux CD, right? Maybe I can show you in this example, okay? During the Docker and Kubernetes, this GitOps we use very often. Like 2 example, maybe I'll just show you here with one with GitOps and one with the normal CI/CD. Okay, but first let me just show you this with normal CI/CD based approach, and then I'll talk about how people are like doing this GitOps based approach, especially for the Docker and Kubernetes like this type of solutions. So the picture will remain same here, right? Especially for Docker and Kubernetes CI/CD pipeline. Okay, so let me just add here CI/CD for Docker and Kubernetes. Okay, so again, the concept will be same here. It means we'll be having the code repository. Okay, so GitHub, GitLab, Azure DevOps. Okay. And then we'll be working with the development team, right? So you'll be having the developers, who are going to write the code for you, and you'll be having the DevOps guy going to work on source code. Okay, and as I said, it could be in any language, right? Like in Python, it could be Java or extra. And the next part would be the DevOps engineer. And this time, now we are talking about Docker and Kubernetes, right? So let me just add here. He'll be responsible for Docker file. He'll be responsible for the Helm chart. He'll be responsible for Kubernetes manifest file. Okay. Actually we call them as like a YAML file, right? Okay. So here, what we will be doing, right? Let's go ahead with again Jenkins and Azure DevOps type of a setup. Okay, then I'll talk about that GitLab, GitOps concept. So here we'll be having let's me just create one box here, and let me say Jenkins and Azure DevOps. Okay. So here this time what we will be doing, right? The stages will remain same, right? So we'll be having git links here. Okay. We'll be having lint. Okay. So this time what I can do, I can have the Docker lint. I can have the Helm chart link. Okay. So I can perform this two, right? These three stages early, right? So if there's any git leaks, okay, if there's any token or any sensitive information, okay, so this git leak stage is going to notify me, right? Okay, or the pipeline is going to fail immediately. And Docker lint, right? So you have to run this Docker lint command, okay. You can see here we can validate, right? We can validate this Docker file is created correctly or not, right? Even you can use header lint. Okay, there are I would say many options, but these two are very famous. Okay, so header lint. So what it is going to do is going to check that the Docker file is created correctly or not, right? Let me just show you some examples. So what I can do, I can simply use this particular image. Okay, and this we even you can see here 50 million means people are using this Hedolin very often, right? So I can simply use this one just to check that you are following all the best practices or not, right? Means I'll just show you one Docker file, okay, just for your like reference. So here, let me just open Python, okay, sample Python here. So in real words, maybe let me see if I can show you a sample. Yeah, this one. So here, yeah, in this example, you can see here, this is how that, the Docker file will look like, right? Where, the people gonna use, one base image, right? Which would be based on your application, right? The development team is going to tell you that they are developing the code in Python like 3.9 version, right? And you can see here there are some other like Docker commands. We'll do all the lab, by the way, during our Docker session. But let me just talk right what exactly we are trying to achieve here. And you can see here there are some other instructions. Okay, we have add instructions. I can perform, I can install some dependencies here, right? Pip install request, and this beautiful SOAP 4. And then finally I can run the Python commands, means Python processes can be started here. So this is one of the example, by the way, right? Now question is how I'll get to know that this particular Docker file is following all the best practices, right? So here this Hedolin will come in picture here, right? So Hedolin is what is going to do is going to check that, okay, are we following all the best practices, right? Means I need to ensure that this Docker lint, okay, mainly I'm going to use a kind of a Hedolin, okay, through which I can check, are we really following all the best practices? If not, okay, then it gives you error basically, right? Okay, it gives you some warnings, right? Then your pipeline is going to fail in very early stage, right? So I can have one Docker lint, right? And I can use this Hedolin, as I said, this is like one of the example where I can verify that I'm doing all the best practices or not. Similarly, I can do the Helm lint here. Okay. So again, it means, are we really following all the best practices? Means if there's, what happens? People usually, people consider that if there's any sensitive information, right? Or if some variables are not correct, right? Or you're not following the best practices, right? So what you can do, you can link, in your CI pipeline only. So here, what this first three stages is going to do is going to check that is there any sensitive informations, are you following all the Docker related best practices, are you following all the Kubernetes related best practices? If yes, then we can execute the other stages, right? So here what I'm going to do, I'm going to build the Docker image, right? So Docker build, okay, Docker image build, right? So whatever the Docker file that you have created, right? In this Docker file, I'll be having the Docker related instructions, okay, some Docker related instructions, and I can copy my artifacts. I can, even create a final image, right? This would be very much similar to this artifact, right? So earlier in the previous diagram, what we did, right? I said generate a deployable package, right? So here I'm going to this particular stage Docker image build, which would be like very much similar to this artifact here. Next, what I can do, I can upload this image, okay, this Docker image, this generated Docker image to a particular repository. So Docker push, right? And I can store this image, I can upload this image to either Docker Hub, okay, store in Docker Hub, or you can use AWS ECR. Eventually, we'll do a lab with AWS ECR. You also can store this image in your company manage Docker registries. Okay. In the real world, in most of the cases, you will see either AWS ECR or Azure ECR. These are, these are like two services, by the way, in AWS and Azure, where the Docker images can be stored, or you also can use your company manage Docker registry. In most of the organizations, you will see like JFrog or the Nexus, right? Or your company manage registries where all the Docker images can be stored here. So this Docker image is nothing but what that that going to contain your applications here. Let me just add here in this Docker image, you'll be having your application component, okay, your application related data. Okay, so now you'll be having the application related data in the Docker image, and then this Docker image can be stored, at one of the like secured location. Now, finally, this Kubernetes part will come in picture here. Okay, so deploy to Kubernetes dev. Okay, so now what I can do, first I can deploy to my Kubernetes dev environment, right? Means whatever the Docker image that we have created, right? Is that image working properly? So here your dev environment will come in picture here. Okay, so the Kubernetes environment, let me just use a different color here. So this would be your Kubernetes dev, and I can use AWS EKS, AWS Kubernetes services, or I can use Azure AKS, right? Or I can use Rancher. There are tons of options we have. So now what I had to do, I had to create a dev environment. Okay, Kubernetes dev environment, and just to create this dev environment, I'm going to use one of the Kubernetes solutions, right? So AWS EKS or Azure Kubernetes services or Rancher, right? Or I can deploy to GCP as well. So now what will happen? This particular, part will come in picture. Let me just add this picture. Okay. Let me add a line here. So now I'm going to deploy to the dev environment here. Okay. So the moment you deploy, okay, the moment you run this particular stage, deploy to Kubernetes dev environment, right? So here, you'll get a pod. Okay, you'll get. Let me not go in technical detail right now, but you finally your application gonna run here. Okay, and let me just add here, run your application. So here, you'll be creating a pod, right? And in this pod, you'll be this Docker image. Okay, this pod would be based on the Docker image, right? The Docker image which you have created earlier, right? So finally, so this image, okay, will be used here, right? Just to create a pod. So the moment you run a pod, it means your application is up and running here. So now, we just talk about like this Docker image build. We talk about the Docker push, right? We talk about one particular stage, deploy to Kubernetes dev environment. Like first let's deploy to the dev. So here, as I say, what I was talking about, like this in this dev environment, what happens? Whatever the Helm chart that you have created, right? Ultimately, is going to create a pod. Let me, as I said, let me not go in that technical detail at this moment. But pod is like one of the unit or the smallest unit that we usually create in the Kubernetes. So if your pod is running, it means your application is running. Okay, you'll be able to access, you'll be able to deploy your applications here as a pod. You'll be able to run your application as a pod here. And in this pod, okay, the Docker image which we created earlier will be used here, right? So if your pod is running, it means your application is up and running. Okay, now you can ask your development team to verify. You can ask your development team to just check all the features, and if everything is working, then we can replicate this picture, okay, to make the QA environment, right, and the prod environment. The similarly, we talk about like in our previous diagram. So you can have QA environment, you can have the prod environment, right? So here you can create a pod in QA, you can create a pod in prod environment, right? So this would be Kubernetes QA environment. Again, we can use EKS or Azure AKS services, and this would be the pure prod environment here.
Prakash, I have one question. So if suppose we are going to use Ubuntu as an operating system, so how many Docker image we can create in one single Ubuntu operating system?
So you can create number of images, right? So consider that your image, your Ubuntu instance size is considered, okay. You have like 2 core and 8 GB of RAM. So usually the Docker uh, container size, right, or the image size, like in MB. So in one VM you can run around 10 to 20 containers easily. Okay, it depends on your Docker image size, by the way. But usually, okay, in the normal case, we can run 10 to 20 containers, right? And if your image size is your application size is huge, right? Consider that your application size, you are developing some consider that some GenAI related like a project, right, where the size would be in GB, right? So definitely you need more, you need like a kind of a very big environment, right? Or you need you need to ensure that your VM configuration is very high, right? So you can run one or two pod, right? You can run one or two containers. Yeah.
So that totally depends upon the memory and the CPU core,
Yeah,
vCPU, how much we are using.
exactly.
Yeah.
So this is how that picture will look like. And again, we can add Sonar here, right? I not added those stages, by the way, but the same stages can be added here. Sonar and execute test cases, right? Those stages can be added here. So in case of Docker and Kubernetes, this is how my pipeline gonna look like, right? And we can deploy to different Kubernetes based environment here. Okay, so any questions now from this diagram? The diagram which we created in previous, right? The diagram, the old diagram, right? And this diagram, they both are almost similar, but here the concept, right, would be like bit different here, right? So early in the previous diagram, we were creating what? The artifact. This time, we are creating artifact like as a Docker image, right? And we have to store it like somewhere, spatially, in like Docker Hub services, right? Or AWS based uh, container registry services, right? Example, AWS ECR, okay, Elastic Container Registry, or Azure Container Registry, right? Or your company managed registry. In most of the cases, you'll see the company managed Docker registries because they are like very much secure and managed by your organizations, so we can store all the Docker images here, like application related images here. And then finally, you can deploy to dev QA and production environment. This is how the big picture will look like. So now just think, right? Okay, you are DevOps expert, okay, you're DevOps architect. Here, what the things that you had to do, right? So here, even if you see this picture, right, you have to create a particular stage, right? You have to create a particular stage called deploy to Kubernetes, and using this stage, you can deploy to the Kubernetes. Okay, means you have some control here. You have some control when to deploy, when to not deploy, right? You can add some triggers as well. You can set this trigger to manual. You can set this trigger to automated, right? So you'll be having some controls, right? But just to achieve this picture, you have to do a lot of efforts, right? Then this GitOps concept came in picture. So in the GitOps, you don't need to actually do such, this basically this deployment part, can be like automated here, right? So in the GitOps, what would be the difference actually, right? So as I said, the most of the, this picture will remain same almost, but in GitOps, the process or the concept would be slightly different. So here, let me just copy some portion from this image. Okay, so in GitOps, okay, uh, we would need the Jenkins, we would need the CI tool, okay, means the Docker image and those things can be created and stored. I'll do one thing. This time let me make this image a bit small. So this would be your continuous integration tool like Jenkins and Azure DevOps, okay, where you can create the git links. Let me just add git links, Docker lint, Helm lint, and build Docker image and push Docker image. Now, some stages will be there as it is, right? Even the Sonar and those, the default stages. Let me add here SonarCube and unit test. Okay, so some stages will be there as it is. Especially in the GitOps, what happens? Okay, in your Kubernetes environment, I can use Flux. Okay, this would be your Kubernetes cluster. So in the there are multiple tools, by the way. Let me just give example with the Flux. So in Kubernetes, Flux, okay, is like one of the GitOps tool. Okay. Right. So here in the Flux configuration, okay, what we can this tool will run right on in your Kubernetes cluster, which will look for the repository. Okay, here it will look for this particular repository. Okay, this time the deployment process is a bit different, right? Just double check. I mean, just focus on this particular process. So Flux, what it is going to do, it look for the repository, where you have the code, right? Okay, it look for the repository where you have the code, right? And if there's any changes in the code repository, especially we can set a particular branch. Let me just add here the main branch or the master branch. Okay, we can also tell to look for which particular branches. So in most of the organizations, we usually set look for only pull the changes only and only from the main branch or the master branch, right? With the branch which is like approved, right? Or where you have all the latest changes, right? Or the approved changes. So what this Flux is going to do is going to look for the repository, and if there's any changes in the main branch, then pull those changes to Kubernetes, right? So here, now I can set interval as well, right? I can, let's say, if I'm going to set interval of, let's say, 5 minutes here or 2 minutes, okay? You can set, you have the complete control. Interval of 2 minutes here. So what it is going to do, Flux is going to check to this particular repository in every 2 minutes, okay? And if there's any changes, so what Flux will do, Flux will pull those changes back to the Kubernetes cluster. Means consider that you have a particular change in your Docker, right? Or your Docker image is updated, right? You have the new code, you have new changes, right? So those changes will be pulled here, okay? And what this Flux is going to do is going to create a new pod here, right? So consider that you have like 2 versions here, okay? The old version of pod, right? Old pod and the new pod here. So Flux is going to, if there's any change, so here Flux, what it will do, it gonna create a new pod immediately with all those changes, and the old pod will be deleted, right? So this is how it works, right? So you can use Flux. Even there are more tools like we have Ergo CD, right? Ergo CD, is a dashboard, right? You'll get the dashboard. You can do all the configurations from dashboard directly. So you don't need to write anything. Flux is going to be is a kind of a file-based tool, whereas Ergo CD, both are the GitOps. They both follow the GitOps concept, and the concept will remain same here, right? In the Ergo CD or in the Flux configurations, what you can do, you can look for this particular repository, means you can give the path here. You can set an interval as well, okay? And if there's any changes detected, like after 2 minutes or after interval of 5 minutes, those changes will be pulled back to their Kubernetes cluster, and your those changes will get deployed here, right? So your old pod will be deleted and the new pod will get created, right? So I can say that, let's say 1.1 version, and here you'll the pod version would be 1.2, right, with the latest changes. So this is how the deployment process will look like, especially in the GitOps CI/CD. So let me just add here CI/CD with GitOps process.
Hi, thank you for explaining the GitOps concept. But even during the other pipelines, like when you're using Jenkins for the entire pipeline for CI and CD, there are webhooks on GitHub. So whenever there is a change in the code, it would automatically trigger the pipeline again, and it would again build and again deploy. Isn't that the same thing?
Correct. So here, like this is a very traditional way, right? Traditional way of doing the deployment in Kubernetes, right? Where you are like using Jenkins, or you are using Azure DevOps. So not you are using Jenkins not only for the continuous integration, but you are using Jenkins for continuous delivery as well. You can see in this picture, the last one, right? So here, as I said, right, you have to still rely, right, on Jenkins for this particular change. So the problem here is, as you can see here, now I have to perform the git lakes. I had to look for the Docker lint, right? Okay, and then my image will be built, right? My Docker is going to push the image to a particular Docker registry, and then last the deployment part will come in picture here, right? So here, time, if you ask me, like one of the drawback of this particular, this traditional way is time, right? It's taking time to deploy to your particular environment here, right? So why to wait a lot? Why to really wait a lot? Like, can we reduce this build time? So yes, we can reduce the build time here, right? Having this GitOps based approach. So the moment you change, like, let me just give you like real examples. Let's say as a developer, if you update a particular change at, like, let's say 9, today's dot 9:59 in my case, so let me just add here 9:59. And if you, as a developer, if you do any changes at 9:59, and as per the current diagram, right, where I said do the deployment after 2 minutes, right? Okay, the interval is like 2 minutes, right? So if you do any changes in your code repository, okay, so consider that at 9:59 your code repository, this GitHub or GitLab or DevOps repository will be updated, right, at 9:59. Now what will happen after 2 minutes? This Flux is going to look for this repository in in every 2 minutes of interval. So immediately this pod will be created at 10:01 p.m. Even you can set this interval to 1 minute, right? If you want, if you want to like reduce the this deployment time, right? You can set it to 1 minute as well. You can set it 5 minutes. You can set it it, like, you can schedule as well, right? You can whatever the number you want to do. So as you can see in this picture, what is happening the moment the developer, right, the moment the developer updated the code, do any kind of changes in the code repository, immediately those changes can be deployed, right, to your dev environment after a minute or after 2 minutes.
Okay, but don't we also have to update the registry, the Docker registry, so it has the
Exactly.
okay.
Yeah. So here, that's why what usually I had to do, I had to double check, right? How much time my Jenkins is going to take. Jenkins, is going to do like changes, right? Or how much time my Jenkins is taking to build this image, right? Then I can say accordingly, I can set this interval here. Right, so still I'll be having I just for reference I just gave the interval of 2 minutes, but in real words usually we set 5 minutes is like a good number, where in every 5 minutes this Flux and Ergo CD is going to look for the will look for the repository, and if any changes detected, then those changes will be immediately pulled into Kubernetes cluster.
So Prakash, instead of pulling the repository, can't we add just one more stage under that Docker build where we can perform a direct deployment on the cluster?
So you can see here, yeah, you can see, as I said, this is a very traditional way. So yes, you have the traditional way of deploying to the Kubernetes environment here, and you have this new concept called GitOps as well.
So I'm just trying to. I'm sorry. I'm just trying to clarify here. So are you saying that after the first time you're building the pipeline, so it will go through Jenkins and then it'll also build the pods and it will deploy. And then if you're using Flux CD or Argo CD, you don't have to build the image again. Does it skip the CI part and just go to deployment and just create new pods?
So what happens, like in real world, I mean, this is like too early to explain, but let me just answer. So here, what happens in real worlds, we never create the Docker image with the latest tag. Right? We have to tag with some, either based on like date or based on the semantic version, right, or based on the build number, right. So then we would be able to really deploy in the production environment or in the dev environment, right. So here, what happens? If you are following the GitOps based like concept, right, if you want to override some variables, you can do that, right, because Flux CD and the Ergo CD, they allow you to do like a lot of configurations. Okay, if you want to override some values like for dev environment, you can do that. If you want to override the value for QA environment, you can do that. If you want to override some values for production environment. So the benefit of this GitOps and Ergo CD is what you can use the single Helm chart, right, and based on your dev environment, based on your QA environment, based on your production environment, you can modify, you can override those values, right, on runtime. So there are not just one, but there are many benefits of having this GitOps approach.
So Prakash, if I understand you correctly, for the GitOps, there are no manual approvals.
Okay, so here, as you can see here, like in this picture, I can like I don't need to have any kind of approvals here, right? Because if my process is smooth, right? If I as you can see here, I'm performing a lot of stages before building the Docker image. Especially the Gitlix is there, right? And also the Docker lint, Helm lint, right? And Sonar. So what I can do, I can have some conditions here, fail conditions, right? If any of the stage, okay, I can have some condition here. Let me just add here, fail the pipeline. Okay, means my new image will not build here, right? So we can fail the pipeline if report is not good, right? So here, what happens? Your new Docker will not be built, right? The new Docker image will not be built, right? Then you don't need to really worry. So here, we need to ensure, like, especially if if you're using this GitOps based approach, and this is a very new way, right, of deploying to the Kubernetes based environment, because you don't need to really focus on the Jenkins. You don't need to create separate like stages. Like if I go ahead with if I really talk, if I really compare with the this traditional way, right, where we earlier we used to create like this particular stage for dev, QA, and production deployment. So now we can avoid having such stages, right, using this GitOps. So yes, it's up to you. If you want to have approvals, you can have the approvals as well in the GitOps. Yes, it's also allow you to do the approvals. Okay, and you can have no approvals as well, right? So it's up to you how you want to configure this Ergo CD and the Flux CD.
But Prakash, isn't that GitOps pods, maybe Argo CD pods or Flux pod running on our Kubernetes cluster? It's something overhead that we need to manage. try to simple one deployment stage in our Jenkins file? Because see, anyhow we are polling the changes every 2 minutes here, and then if there is new changes or new version of uh, Docker image available in the repository, just pull that and deploy that. So this is a simple thing. We can also do that using our traditional approach, directly push that changes once that image is built.
So
No need to manage this overhead of Flux CD and Algo CD.
okay. So
I'm just,
if you
I'm
know,
just trying to get what's the real rationale behind this GitOps approach, because uh, it's again we're gonna increase the overhead of DevOps guy, right?
no. Here, if you let me just answer right your question. So here, the first of all, the size of this flux, is just I would say in MB only. Like in real words, if I really not wrong, the size of this particular pod would be just 20 or 50 MB, right? So here, this is one of the best, one of the advantage, right, of having the Flux CD, because now I don't need to like worry about creating a particular, let's say, the problem with this Jenkins is what, right? If this Jenkins is failed, right, then my entire deployments, this process will be failed, right? Because I have to maintain like multiple Jenkins servers. Okay, I need to ensure that my Jenkins is up and running all the time, right? Even multiple agents need to be created. Security, you need to ensure that you are storing your credentials in your Jenkins. So a lot of concerns will be there, right? And having this GitOps based approach, the very first advantage of having this GitOps is like size of this Ergo CD and the Flux CD is very less. The second thing, now I can reduce my deployment time here, right? So nowadays, if you're looking for more, I would say the quick result, right, then GitOps is one of the best approach that you can have in your organizations. So here it reduced my build time, sorry, it reduced my deployment time, because within a fraction of, I would say, within a minute, right, whatever the interval you have set, right, within that interval your application will get deployed to dev queue in productions. So no need to, and one of the best part is, if you ask me, the Flux is just like one time setup, right? And hardly you need to update it, right? Whereas if you are going ahead with this Jenkins and Azure DevOps based or the traditional way of deploying to the Kubernetes environment, the problem is you have to update it very regularly, right? Okay, you have to some human intervention is required, as I said right earlier. Human intervention is required. You have to do polling right, again and again. So those things can be avoided, right, having this using this GitOps based like concept. Yeah. So yes, there are some advantages, but if you are completely new, okay, I mean it's up to you. It's up to your organizations, as I said earlier. Because still, yes, we go ahead with the traditional based deployment strategies, as well as we go ahead with, we can still go ahead with the GitOps based concept, where Ergo CD and the Flux CD can be used as a deployment tools, right? And these two are open source as well, right? So I don't need to spend a lot, right, on the tooling part here. It's just one time setup, right? I can say that. And also overriding variables is very simple in Flux and the Ergo CD. So yes, there are advantages as well, and yes, some disadvantages as well. I'm not going to deny it, but it's up to organizations to organizations, whatever the best we can choose. So yes, this is how that the pipeline in Docker and Kubernetes will like look like, and we'll focus on this picture, right? And we'll focus on this one as well. Yeah.
I just want to check, is it possible to do that in GitLab as well, where we can convert the build into a Docker image?
Yeah. As I said, yes. Answer is yes. As I said, like these are, you can use Jenkins, you can use Azure DevOps, or you can use the GitLab runners here, right? So these are the build tools, or I would say, the continuous integration tools. So yes, they all have, features. They allow us to generate Docker image. Okay, so now let's do one thing. Let's go to the PPT, because we haven't touched this PPT. But now I think most of the things are already cleared. But let me just go ahead. So as I said, this DevOps, right? as I said earlier, right? So DevOps is like, the process, right? Okay, is all about like the process, is all about the plan that you are going to create, right? It's not about the tool, by the way. As I said, you are completely free to use any tool, right? And so DevOps is like a union of people, process, right? Product to enable the continuous delivery. Just now, we talk about this continuous delivery approach, right? Where we can we can deploy our solutions for the end customers, right? DevOps is not just automating, a pipeline, right? So as I said earlier, you can in this example, right? As I said, this particular, the red line where I said we can send a notification to the development team, right? So having this DevOps based approach, right? Okay, we can immediately notify our developer that the particular error is there, right? Or some test case, some test cases are failing, right? Or the code is not compiling properly. So what we can do, right? We can immediately have this DevOps based approach here, right? And we can have a continuous integration and the continuous delivery process, right? So the final goal would be, we would be able to deploy, we would be able to release our product, right, in a very short time frame. So even as I said, right, we can have deployment on daily basis, we can have deployment on weekly basis or the monthly basis. It's up to organizations to organizations, right? And you also can see here, like earlier, we used to have this waterfall kind of a strategy, right? And this is very old one, by the way. Earlier, people used to like used to have this waterfall kind of a strategy. So just think in that way, right? You are like developing a kind of a house, right? You are building a house, right, step by step. And once you finish the foundation, then only then you can make a wall, right? Then you can make a roof. So here you have to go step by step here, as you can see, step by step here. And it is really difficult for you to go back and change the foundation, right? Because once foundation is done, right, and on top of it, if you're adding like a wall, right, then you won't be able to modify the whole foundations, right? You have to break everything, and then you have to build it from scratch. So in the waterfall, this is very I would say the deployment cycle was not that simple, and it used to take like a year, right? In some cases like a 2 year or 3 year, right? So then this agile came in picture. Okay, so like building blocks, right? Here we can say that some improvements were there. Okay, now people can do frequent check-ins in the code, right? And we can provide the feedback in very early stage. Okay, but the main problem was in the agile, this deployment was not that smooth, right? Whereas in DevOps, okay, you can see DevOps is all about like planning, right? It's all about like the people. Okay, is all about like having architecture, right? So we can plan. Okay, we can plan. We can, let me just zoom this picture. 1 second. Okay, you can see here in the DevOps like process, we can plan, we can do the code, right? We can build the code, we can test, we can release, we can deploy, right? And even we can monitor, right? So all the processes can be can run at the same time, right? And it's easy for us to modify. Okay, and in case of like DevOps, we would be able to deploy the microservices, especially for like the Kubernetes. Nowadays, we usually deploy the microservices, right? We can create the containers, right, based on the Docker images, and we also can have deployment in cloud, right? So, okay, and you can see some like forecast DevOps revenue, and as we know that eventually this DevOps as a DevOps engineer, you need to work on AI operations, you need to work on ML operations, right? So, and trust me, this DevOps involvement, right, is not into the CI/CD creation, But there are various topics, okay, are there where this DevOps involvement will be there, right? For example, the FinOps, okay? FinOps is like something new, or some of you're like already working on. So FinOps is like one of the area where DevOps involvement will be there, right? AI operations, ML operations, right? So SRE, right? Platform engineering. So DevOps has like multiple branches, right? And you will see this DevOps involvement is going to, I mean, people is going to use this DevOps based like approach for different like the use cases. Okay, so this like opportunity, not just in like DevOps area, but SRE area, cloud engineer, like platform engineering, AI operations, ML operations. You will see multiple other opportunities will be there, especially in this area. Right? And the DevOps life cycle. Let me. So here, we would be following this life cycle. Okay, first, we'll talk about this story, right? We'll talk about some development tools. Especially, we would be using the VS Code, right? So try to install the VS Code on your system. Okay. Then is a code repository. We would be using the GitHub and the Azure repository. And for building the code, right, we would be using Jenkins, we would be using the Azure DevOps, right? We'll use the SonarCube, right, and some build tools like Maven, okay, and the Docker, and then finally, we'll deploy. And this infrastructure code, right? So Terraform, right? We'll see how the Terraform can be used to provision the environment, right? The two-tier architecture, the three-tier architecture, how the instances can be created, how the Kubernetes cluster can be created. And then this Ansible part will be there, right? Where you will write some script, okay? And we'll create the playbook, right? And we'll see how the environment can be configured, right? And then finally we'll be having dev, test, and production environment. Okay, so we'll create like a complete life cycle, right, based on this picture. Well, like why DevOps? So I think now you know very well, right? Because having this DevOps based approach, right? We can reduce the build time, right? We can work with the developer. Okay, we can provide the feedback immediately, and this particular problems can be fixed, right? If system is the particular tool or the particular code is like working on my system, okay, on the particular code is like not working on the other system. So this is a very genuine problem. Sometimes people also see that like the same application works on my system, but the same application doesn't work on the other system, right? So such issues can be avoided. And now we have the Docker as well. So Docker is like a platform independent, right? If it's going to work on my system, so definitely it's going to work on any system, right? Be it cloud or on the local Kubernetes based environment, right? Because it's completely platform independent, right? So these problems can be avoided. Okay. What and why DevOps? I think just now we talk a lot about this particular picture. Mainly, we would be using this DevOps based approach for communication, collaborations, right, and integrations with the development team, with the operations team. So here, the operations team, like you can say yourself as like operations guy, right? You'll be responsible for the managing your environment, managing resources, managing applications, right? And you need to ensure that they are highly available, right? So a lot of things that you have to do in the operations part. Okay, and we'll see that. Roles and responsibility, I think just now we talk about that, right? We have to ensure that this environment we are going to create in an automated way using Terraform, right? Writing the CI/CD script, writing the Docker file, Kubernetes, Ansible playbooks, right? Helm chart, okay, Docker files, and then you had to create the kind of a roadmap. You have to create the environment infrastructures, right? And also you need to focus on the monitoring part, right? Okay, how you are going to monitor your environment, how you're going to monitor your pipelines, everything. So yeah, these things will be there, and you'll be in the real words, you'll be responsible for not just CI/CD, but you'll be responsible for many other like activities. Okay. Then I think just now we talk about this. DevOps, works with agile, lean process, right? ITSM process. Okay, we know we have to follow some ITSM processes, right? And as a DevOps engineer, like who should learn the DevOps, right? So not just developer, tester, system operations. Even nowadays, the people who are coming from other background, like especially the business analyst, right, or the product owners, okay, and the managers, right? So this DevOps process, the involvement of DevOps is everywhere, right? So the person who is coming from not just the operation side, but the person who is coming from different background, they have to learn, because the involvement is everywhere. Tools and technology. So as I said, especially for coding activity and for planning, we use Jira and the Confluence, right? We use the Confluence for documentations, Jira for ticketing, right, and Git for the code commit activity, right? For build, we'll be using Maven, okay. For test, we'll be using JVNet, right? Okay, and Selenium as well, right? Jenkins, we will be for the CI/CD activity, Jenkins and Azure DevOps, okay. For deployment, we would be doing deployment on AWS VMs and the Kubernetes. And the operation side, we would be using Ansible and Kubernetes, and also the monitoring part, right? So you'll see like lot tools, and there are tools in different areas. We have tools in monitoring, orchestration, configuration management, deployment, testing. We have tools in code review. We have tools for build and software like repositories, right? So you have tools, and we would be following this particular like process, okay. Even you can just now we already talk about like this flow, right? Planning is like needed. Code build, you have to ensure that you store the code like on one of the code repository. Build part will come in the picture. You have to execute your test cases, and then you have to do the release planning, right, to dev key and production environment. And then you have to operate, means you need to ensure that your environment is up and running, your applications are there, right? So you can use different tools as well, okay. And finally, so in Azure DevOps, the tool part would be a bit different. Azure board, right, where is like similar to the Jira, right? Jira, where you can create you can create plan, you can create tasks, you can create bugs, right? Azure repo would be somewhere sit here, okay. Let me just add here. I think we already have added here this Azure DevOps or repo, okay. So this would be the repository where the code can be stored here, right? Let me go back to this picture. Then this Azure pipeline, where we would be creating the build and the release pipeline. And then you can have this test plan where you can perform all your test cases. Azure artifact, right? So Azure has we can use S3, right? We can use Azure artifacts just to store all the artifacts, right? So these are Azure related CI/CD tools, right? That we can use for continuous integration and the continuous delivery pipeline creation, right? And we will be doing a lab with Azure based tools. This is how that dashboard, Azure dashboard will look like, okay. In the left side, you can see here you have the board options, you have the repository options, you have the pipeline, you have test plans, artifact, right? And this dev.azure. So you have to, like, later on you have to create your account, right? We will be creating account, and we'll do this lab. Code repository, we talk about the Git. So let me go ahead and talk about the tool. We do have this code commit as well, okay. This is very much similar to here, yeah. Okay, you can use this development team can use the Git as well as the code commit, okay, for code just to push the code to the code repository, right? The Maven, we would be using as our build tool, right? So we would be creating the artifact, right? We can perform test, we can perform compilation, code compilation, right? So we would be using Maven as a build tool. And in this picture, right, okay, in the previous picture, even I showed you here. So we would be using Maven, right, for code compilation. Even I just noted down some tools here for code compilation, for generation of artifact, right? So this Maven can be used. So we have Maven, we have Ant, we have Gradle. So these are some tools. Okay, these are some build tools. For testing, we would be using Selenium and JUnit. CI/CD, we talk about we talk about the CI/CD already. So let me just jump to the other tool. For CI/CD tool, Jenkins. We will be using Jenkins and the Azure DevOps, but there are some other tools as well, like we have Circle CI, Travis CI, Bamboo, AWS Code Pipeline, and CodeShip. But if you ask me, Jenkins, GitLab, Azure DevOps, GitHub Actions, these are the primary tools, right? Okay, and they have captured more than like 90 to 95%, right? These 4 tools. And as a DevOps engineer, you should focus more on like Azure DevOps and Jenkins. We would be doing a demo with Jenkins, right? So mainly, we can use it like for the continuous integration activity, where code, the code can be downloaded. So this checkout, like the code SCM checkout, we call this like SCM checkout. Code can be downloaded from the Git repository to the Jenkins. Then we can build it, we can perform the test, and we can have like other stages as well. So this is how that pipeline will look like. By the way, you already have covered, right? And we talk about this GitOps process. So Ergo CD is like one of the tool, right? We'll be having infrastructure provisioning, Terraform, okay, and the Ansible. These 2 are the tools, right? And Docker Kubernetes. Just now we talk about this. We'll go in detail later on. By the way, especially for Docker and Kubernetes, we would be creating completely from scratch. The Docker file will create from scratch. We'll learn the Docker commands and how we can operate in the Kubernetes, right? So that part will come in picture. Then we have this AKS, EKS, and GKE, right? So these are some cloud provided Kubernetes solutions, and they are in different cloud vendors, right? Monitoring side, Prometheus Grafana, will do a lab with Prometheus Grafana as well. Okay, so we would be we have to ensure that the environment is up and running, right? Okay, the applications are up and running, and if there's any error, then we have to detect in very early stage, right? So this Prometheus and Grafana are the tools, okay, that we would be using. And for scripting, Linux, so we'll start with Linux first, okay, because as a DevOps engineer, this is must, by the way, right? Even in this picture, right, I said, okay, you had to write some deployment script, right? So you need to ensure that you at least know like Bash, okay. Okay, there's one question from Niroj. Do we store DevOps code within the application source code repository? What are the standard practice? Yes, Niroj, yes, we can store. Definitely, we can store. Like, okay, because along with like along with the development team, right? Okay, because what we have to do in real world, right? Okay, we can we have to deploy the code, right? So we should now this Docker file, Helm chart, they're part of the code, right? So yes, we have to store in the code repository. Question is, can I have some template, right? In a separate repositories, can I call those template in my CI/CD? So yes, is also possible, right? Okay, then thank you all, and have a great day ahead.